All right, Sean graciously loaned me his spectrum analyzer, and I'm going to use this in the Insight to find the IMA's radiated noise, if it is radiated, and if not, we'll use the same instrument to find the conducted noise later on. So I just wanted to show how it works a little bit before I put it in the car. This device basically measures the frequency spectrum, and it measures it up to 1 gigahertz of analog bandwidth. So that includes, the FM frequency spectrum, and it includes, digital broadcast television and CDMA on cell phones, for example. Certainly, the aggressor signal, if it is radiated, is going to be less than a gigahertz. There's really no way that noise above a gigahertz would be an issue, and I'm not going to go too much into the details on why, but it has to do with the shielding in the car, etc. So this instrument is on the older side. When it was new, it was about 30 grand. It's not that much anymore, but it is still very useful. There are certainly much smaller instruments that do the same thing nowadays, but they're also expensive, and this, even though it weighs 60 pounds, is quite a bit cheaper. And so Sean dropped it off the other day, and I happen to have a GPIB device which allows me to communicate with it, so I cannot have to use its old screen. But more importantly, it lets me set some of these parameters here. So for example, right now I have a center frequency of 500 megahertz with a 1 gigahertz span, so that's the entire range this device can digitize. And so I'm going to go ahead and set that, and then I can basically grab frames from it. And what I can do actually is grab multiple frames, and you can see I'm overlaying the spectrum here. So these are just the various RF devices that are broadcasting in my house right now, cell phones and whatnot. For example, if I go to peak detect on this, we're going to get a peak hold, and I'll reset this, and we'll get a first frame here. And you can see here's a baseline, and now I'm going to click the key on the Insight, and I'll click it a couple times to make sure we find it in here, and then we'll grab a new frame, and you can see there is the frequency that our key was going at. Now I previously went in here and figured out that it's 307.8 megahertz, and so if we come in here and set our center frequency to 307.84 megahertz, and then we'll make our center span say 10 megahertz, and we'll go ahead and clear this, and we'll grab a new frame. You'll see here's our baseline. This is just noise, and so now if we hit our key here a few times, you can see that we have a very obvious peak here right at 307.84. Another neat thing this device can do is we can look at, say, the FM radio. So if we have 100 megahertz with, say, a 20 megahertz span, this would be 90 megahertz to 110 megahertz. And if we grab that frame, you can see these are all of our FM stations, so 88.1, etc. Up here would be 105.7 or whatever, depending on your region. But for example, we could come into 88.1, that's a local station here in Chattanooga, and we could set our span to 250 kilohertz here. And this box actually will play the audio. So we are now decoding the FM, we're demodulating it through an IQ down mixer, and then playing it. But this is the frequency spectrum of that channel, and you can see if we grab it multiple times, you can see, just the frequency modulation here is what makes the sound. Obviously it's hard to visualize it here, but if we go ahead and want to just turn this back off, we can go to, say, 250 megahertz, where there's just going to be static. So here's static, and if we increase our span enough, it will turn off just because it's programmed to do that. But apparently 1 megahertz is not enough, so we'll go to 10, and so now we've squelched out. So anyway, that's how this device works. What we're going to do, I want to show you here back to the full range of this device, 500 megahertz at a 1 gigahertz span. And what you can see here is you can see all of the various noise that's here. Now right now I have an antenna plugged in. Go ahead and zoom out here a little bit, I've actually got an antenna plugged in. So I've got a BNC cable, and then I just have, you know, a 700 millimeter long cable. And so that's acting as an antenna. And what we're going to do is we're going to mount this antenna inside of the IMA bay, and then we're going to try to electrically seal off the IMA bay as much as we can. To do that, we'll use copper tape, and you know, the OEM harness already the OEM bay is already pretty well shielded, and we'll go ahead and shield it more. The eventual goal is that we get this noise level way down, and so I'm going to just spoof a low noise level right now by just terminating. I've unplugged that antenna I just showed you, and now if we grab a new frame, you can see the noise level is actually not low at all. Hold on a sec. I did something wrong. We'll go ahead. Oh, I'm sorry. I have it on peak detect, so that's why. Because it's just storing the peak values. That's okay. So what we'll do is we're going to go to no peak averaging, and we'll go ahead and clear it out. So this is our baseline here. Let me grab a frame. That's our baseline frequencies here. You know, here is 0 megahertz DC, and here's a gigahertz over here. And now when we unplug our antenna, and we grab a new frame, you can see our noise floor. You know, we're 94 dB way the hell down there. So that's what we want the IMA bay to look like. Ideally, it would be, you know, below 70 dBm. This is dBm. Let's see, this goes into the antenna port. And I did just, in case I wasn't completely clear earlier, I can grab as many frames as I want. And what we're going to do is we're going to grab some baseline frames, and then we're going to run the IMA bay for a minute, and we're going to grab some running frames and see where that noise is, because depending on what the frequency is, it'll give us a good idea on how we can block it, you know, with a certain type of filter, etc. And of course, if we go in there and there is no noise radiated when we use an antenna, I'm literally just going to tape this wire to the cover on the LiBCM. If there is no appreciable noise, then we'll know it's conducted noise for sure. So we'll go ahead and run that test. I'm going to throw all this equipment in there, and we'll see how it goes.